I'm back. Here we go. Let's try again. All right, let me stop. Okay, I'm still recording. All right. Can't see my lecture notes. Okay. All right. So I think everyone can see. Yeah, everyone can see it. Okay. All right, let me get started. All right, so let's see. Okay, so basically I'm going to start with chapter 1. And again, the outline I emailed to everyone. And what I'm basically going to do in this chapter is cover those topics, as you can, perimeter, area, and all that stuff. Okay. Basically, so these concepts you probably have seen before. We're going to see some important concepts here, okay? We'll see how to calculate the perimeter of different two-dimensional shapes and the area of certain two-dimensional shapes as well. We're actually going to see volume as well of three-dimensional objects. We'll do a little bit of volume. Pythagorean's theorem, that's a very powerful theorem with right triangles. We'll actually see that as well. And then we'll also see a little bit about circles. Mostly we're just going to deal with circumference and area. You probably have seen these before. I mean, if you haven't, that's okay. But that's really what we're going to cover in chapter 1. So, all right. Now, maybe I don't know if you expect this in math or not, but I know in most other fields, like science fields that is, there's important terminology that you just have to know. Vocabulary, in other words. Well, math is no different. There is important terminology, definitions that's good to know. The first one is actually kind of hard to define what a point is. It's really just a location and it has no dimensions. I mean, in the book, they try to go a little bit more into it, but really that's just what a point is. It's one of those things that's really kind of hard to define, but people try anyway. These definitions also come from the textbook, unless stated otherwise. Not just these, but all the definitions I give. Now, even though a point is kind of hard to define, it's very important because other objects like a line and a line segment are made up of points. A line, right? That's just a one-dimensional figure, and it's made up of infinitely many points. One-dimensional just means it has directions left and right. In other words, it only has length. The line can't go up, it can't go left and right, and it can't go up and down at the same time. It's only one dimension. You can only go east or west. You can't go north or south. And a line also has infinite length, mostly because it extends indefinitely in both directions. A line segment, though, that's when you have two distinct points, and then you have all the points in between. Distinct points just means that the points don't lie on top of each other. They don't coincide. And a line segment, that's just essentially a part of the line. Again, it consists of two distinct points and all the points in between. Again, it's only one-dimensional. It only has one dimension, left and right. One dimension. Okay. So that's one dimension. What about two dimensions? Well, we do have that concept, and that's where planes come into play. With two dimensions, you can go left. Sorry, let me define this first. For a plane, that's a two-dimensional flat surface, and it continues infinitely. In other words, it never ends in each direction. Left, right, and up and down. So in a plane, you can go east, west, north, and south. South you can go. Left, right, up, or down. Planes have 2 dimensions. And again, 2 dimensions you can also think of as length and the width. But there's no height, meaning you can't, how do I say this? You can't come, well, there's no height. That should be, hopefully that's easy to see. I mean, you can imagine with a plane, you can imagine having a piece of paper that's flat, there's no thickness to it, and there's no bends or anything like that, but that paper is extending indefinitely. So there's no height to it. You might have seen planes before. If you took math in high school math courses, I think they go into the Cartesian plane or that XY plane. You have these 2 axes, the X and Y axis. Well, that's a plane. That's a Cartesian plane. From there, we can actually form what are called 2-dimensional figures. Those are just figures you can draw entirely in a plane. You know, you have a rectangle like here. This is 2-dimensional, right? You can go left, right. You can go up, down. You also have triangles. Those are 2-dimensional figures. There's also this concept of a polygon. A polygon is, let me see if I can find it. Yeah, a polygon is a 2-dimensional shape with straight sides, and it's also closed. Let me just quickly say what it means to be closed. If you start at some endpoint on the figure, you can walk along the boundary, like so, and get back to where you started. But that's what a polygon is. So these are examples of polygons. I know polygons, that definition's a little strange, mostly because of the concept of being closed, but we're out of time, so I have to stop here. So let me stop the recording.